Good evening, sir.
Good evening, Bhavana. Okay, so I'm sharing my screen. Alright, I've shared it. Okay, so Bhavana, whatever we have discussed in the previous class, any doubt till there?
No, sir.
So I think we discussed differentiation in the last one class, right?
Yes, sir.
Okay, so maybe we can go with the integration now. Integration. Okay, what is integration basically? Look, when we used to differentiate, what we used to do, we had a bigger picture, okay? And I used to calculate smaller out of that. Okay, here I am going to do the opposite. What does this mean? Basically, assume you are given this thing. This is a graph. Okay, I'm sharing. If I ask you to
Okay, sir.
calculate area of this one, you will say, okay, I have a very easy option. I will go. Let's say this is the area you have given, and I ask you calculate it. So you can simply say, sir, this is the delta x. This is the delta y. I can simply do delta x multiply by delta y, and I will get the area. Is it?
Yes, sir.
Yeah, this is what you are going to do. Okay, let's move to some better picture. What you are going to do in this case? Maybe this. Again, a very simple idea. You will say, okay, let's do one thing. I can do one thing. I will go smaller pictures and I will integrate it for another small portion, right? You will take this one. So what you are going to do is the total area you will say it is nothing but summation, not summation. I can write it as delta x into y1. Let's say each of the delta y x is same, okay? Delta x into y2 plus delta x into y3. Is it? This is what you are going to do. So what is the answer finally you are going to get is y1 plus y2 plus y3 and so on, whatever the n number is. Is it what you are going to get?
Yes, sir.
Okay, now assume this is not what you had to get. You had to calculate something like this. No, not this. Okay, whatever it was, let it be as it is plus yn and delta x. Now I am giving you new thing. Can you calculate the area of this one, or can you calculate the area of this picture? Area of this picture, not this picture. Okay, what I am talking. Okay, can you calculate the area below this picture? Mean to say this is the graph. I am asking you to calculate area between this region. Can you calculate it? So if you see this kind of problem, what is the basic hint you can have? You can say, okay, we have an option. Let's say I'll make it a little bit wider or a bit more. Let's say this is the wider picture, okay? And I ask you calculate from here to here. How you can do this? You will say, I know the total distance. Is it? I know the total distance. Let's say this is how much? Let's say this is the x. This is the x2. So I can say this is nothing but delta x. Can I say this?
Yes.
But I don't have any random figure because this is a very random curve figure, right? It is not a square, rectangle, or something for which area I already know. I can say one thing. So you will say I will go and cut out a rectangle, maybe rectangle. If you cut out a rectangle, you will be getting something like this figure. Okay, the figure will be like this. You can cut out another rectangle, basically very small strips. I am saying go and cut out a very small strip. Okay, but if like okay, we'll just remove it. I am saying go and get the area of this smaller portion. So you will say I am going to do this. But if you take the area of this portion, you will be missing this part. Is it? Bhavna, are you getting this point? Like integration of this
Yes, sir.
part. Okay. So what we are going to do? Okay, let's do one thing. Let's go in a small way or more smaller picture. So you will say, okay, instead of this, I will take this as my strip. If you take this as strip, okay, still you are leaving this portion, because at the end of the day I will try to make strips out of the bigger pictures. Okay, so I will go further till that smaller portion will goes to zero. Understood my point?
Yes, sir.
Okay. And if I get at some point, let's say I am getting, just assume this is that strip. Okay, I can say the width of this strip is dx. Total is, let's say this total length is how much, x. Okay, this strip is dx. What I'm going to do, I will take the same length of strip for a different length. Basically, same width of this strip, but for a different length. That, let's say this is y1, this is y2, and so on. This length is y3 till here. Are you getting my point? So what is the final area you will be getting? Area is nothing but this is length into the breadth. So what is the length into breadth right now? So that is y1 plus y1 into dx plus y2 into dx plus y3 into dx. Understood this point?
Yes, sir.
So what is actually you are going to do? If you see carefully, this y1, y2, basically, if you do this now, you have n numbers. What is this dx? Dx is a very small portion of a very big picture. Okay, for example, if this length might be 1 lakh, okay, if this length is 1 lakh, this dx will be the very smallest strip of 1 meter maybe. Understood my point? Very smaller picture. Why? Because
Yes, sir.
if it is a if it has a significant value, this curve won't give you the proper rectangular shape. Okay, I want to cover each of the smaller piece. If I go to this smaller picture, still I will be having something called this. Okay, I will remove it when I'll reach to the very smaller picture. When this length gets significant, basically I will be covering very smaller portion where I will be getting as a proper rectangular strip. Understood my point?
Yes, sir.
So before this point, what we were doing, we will be like, we had something around significant calculation 10 and 20. We used to go and we used to do a summation of, summation means to say we used to add all of them, right? Here comes up an
Yes, sir.
integration. What I am going to do, I will integrate it. This is called integration. At the end of the day, we are at the end of the day solving it. Okay, but here what I am going to do, I will integrate it. What I am going to do, you can see my dx is constant here. So can I say this is dx and y is varying? So I will put y. My y is like, okay, from where to where I am going. You can see I am looking these change in value of y when I'm changing x. Is it? Because when I was at
Yes.
this value of x, I had different value of y. When I was here at this, I had different value of y. So just assume I must have some relation of y as x. Okay, maybe ax or something.
Okay, sir.
So from where to where I'm going? I'm going from x1 to x2. Understood? So I'll be getting the area between this portion. Can I say this? X1 to x2. When I do this, what happens? When I put x1, I'll be getting this y1. Okay, dx. After this, just x1, I'll be calculating the value. Like this says that you are calculating at x1, then x1 plus very small dx, then x1 plus dx2, and so on. This is what I'm going to calculate. Are you getting a point?
Okay, sir.
Okay.
Yes, sir.
So for each of them, I had y1, y2, and so on. So when I put this, I'll be getting the final area A. Okay. So got the crux. What is integration is all about? Integration of y dx. Understood? Now, when you keep a limit over there, this is a limit. Okay. This is meant to say final value you are having. In this case, okay, I will tell you after this. Let's go for the formula. Okay, of integration. Integration of y is equals to x. I'll start with y is equals to x. Okay. So what is the integration of this?
Okay, sir.
Integration of y dx. In this case, basically integration of x dx is nothing but x to the power n plus 1 divided by n plus 1. Understood?
Yes, sir.
This is followed by a constant. Okay. What is this constant? This can be anything. Why I am putting this constant? Let's see. If I ask you, can you integrate this part? Like, can you differentiate? Let's say I am giving you a value y is equals to x to the power n plus 1 divided by n plus 1. Bhavna, can you differentiate this part and give me the result value? Differentiate. You have to differentiate it. Just differentiate and give me the value. Have you got the answer after differentiating it?
So can you do it once?
Bhavna, you are not able to do the differentiation of this part. N and C are constant, only x is a variable. We have just come up with a differentiation chapter.
Okay, so wait.
Please try. It should be very simple. Bhavna, have you got the answer?
So please do it.
The differentiation of it will come out as, I don't know why you're not able to do this. How you have to differentiate this part? Isn't it a very easy part? X to the power n. N is a constant here. Okay. Plus 1 divided by a constant value is given to you. What is the thing? I told you, just take the constant outside. Okay. What does this mean? This is a constant. You don't have to do anything with this. Differentiate this thing. This part. What is that? N plus 1. Whatever the power, take it outside. It's n minus 1. Okay. Uh, yeah, basically I made mistake. The answer should be x to the power n. That is the thing. So this is what you are going to get. N minus 1. Basically here the power was n plus 1. So this will come out as minus minus. Cancel, cancel. What you have got? X to the power n. 1c was there. This is a constant. Differentiation of constant comes out as 0. Understood? So answer should be x to the power n.
Okay, sir.
Understood or not? Please.
Understood, sir.
So what is the differentiation? X to the power n. Okay. The problem is, what is the integration? If I ask you, dy is nothing but x to the power n dx, right? If I say integrate mean to say get the area for all the values of x. So y is equals to how much you are going to get. As per the previous formula, you can see this formula. If I don't include this c part, okay. If I don't include this constant c, because here you can see what I am going to get. The formula is basically says that answer should be x to the power n plus 1 divided by n plus 1. If you see carefully, in my real value of y, I had a constant value. Can you see this?
Yes, sir.
But if I don't put here constant, that's why this becomes error. Okay, in general, the formula is only this value. But that's why I put the constant, because might be when I was coming to this differentiated value, that constant must have been removed. Okay, and when I integrate this, I don't have any consideration for the constant. So when you integrate it, you have to put a constant c. That c is for all the constant which you must have differentiated as a zero. Is that clear?
Yes, sir.
Okay. Why I feel that you are not getting this point, the integration part. Look, this integration is reverse of differentiation. Okay, what does this mean? We go from here. If you do integration of a, if you do differentiation of a, okay, you will be getting b. If you do integration of b, you will be getting a. Understood?
Okay, sir.
What does this mean? Let's see for an example. Let's say my y is equals to x. If I do the differentiation of dy by dx, I am going to get 1. It means whatever result is, if I integrate it, I should be get the y again, right? Let's say my a, whatever I told you. Wait a second. My a is x. Okay. When I differentiate it, what I am going to get?
One.
1 I am going to get, right? Differentiate. It means these. It means the integration of 1 should be x. In, it means integration of 1 should be x. Is that clear now?
Yes, sir.
Okay. So I can simply say that integration of y, basically integration of 1 dx will result you 1. Is that clear? Basically not 1, it
Okay,
will
sir.
result you x. And I told you, when you integrate it, when you don't have a proper limits, because I didn't specify right from which x you are going, here to here or whatever. So you have to keep a constant along with it. Understood?
Okay, sir.
Because here when you differentiated it, it can be x plus c also, right? The differentiation of x plus c will also result you 1 itself. So that is the case. Okay, let's put the another thing. um Now my a is x to the power n. What is the result I am going to get if I differentiate it? Now what I am going to get? I'll be getting b as n x to the power n minus 1. Is it?
Yes, sir.
Okay, so can I say that difference integration of this part will also be this?
Yes, sir.
Okay, wait a second. Okay, so basically the differentiation of x to the power n, no, integration of n x to the power n minus 1 will result you how much? Dx. Let me write it as dx. How much you are going to get is x to the power n. Bhavna, is that clear?
Yes, sir.
Just assume I am replacing this n with n plus 1. Okay, then what you are going to get is n plus 1 x. This is x n dx. It is nothing but equals to, just a second, I'll remove it, x to the power n plus 1. Now, can I say this if I take this n plus 1, that's it? Because this is a constant. If I take it outside, doesn't make difference. Okay. So x to the power n dx is nothing but x to the power n plus 1 divided by n plus. This is the formula. Okay.
For
Please remember,
integration.
yeah, this is the integration of, look, the differentiation of x to the power n is n outside, in the multiplication n outside, and in power you have to add. What is the integration? In integration, You have to add that thing and divide by addition. Is that clear?
Yes, sir.
Okay, I will give you just one or two more formula. Okay, and then we will try to solve some problem. Okay, won't go much more on this.
So can you
Can
solve
you?
one problem on this
Yeah, we'll
formula?
solve. Just a second, I'll solve it. Just one more thing about the constant. If you have any constant, let's say a and x, you can simply keep it like a outside and do the differentiation of rest of the part. Okay. And another thing is, if you have differentiation of integration of gx plus minus maybe kx, so what you can simply do, you can write them as separate function. What does this mean? Integrate it separately plus minus integrate it kx. Is this clear, Bhavna?
Yes, sir.
Now we will try to solve some problem. Question. The first question is integration of. Okay, I am giving you dy is equals to. I am saying Bhavna, dy is given as x only. Okay, not x actually. Okay, do one thing. Give me the differentiation of 3x square dx. So as I told you, if the constant is there, you can keep it outside. Keep it outside. Now here, if you see, I have a very simple idea. I can apply the formula. X to the power n is equals to xn plus 1 divided by n plus 1. Okay. Alright, that makes sense. What is the n here? In this case, my n is 2. So when you put it, what you are
Yes,
going to
sir.
get? X3 divided by 3. So what you are going to get answer is 3 x to the power 3 divided by 3. Okay, Bhavna, do you think is this is this integration complete or I have to add something else?
Sir,
Every
does that
integration. Yeah, what happened? Does that? Why stop? You were saying something like does that?
so three can get cancelled, right?
Yeah, I know. That can cancel. I have not cancelled. Just I want to take it. Yeah. Okay, Bhavna, do you
Okay,
think
sir.
this is a complete integration?
Yes, sir.
If you see, I told you about the constant value, is it? So every time after every integration, you have to put constant. When you have to keep
Oh,
constant,
oh.
integration of happens in two ways. One is limit, one is without limit. What does this mean by limit? Limit means to say I have specified the range. For example, this is a random curve. I have specified the range that you have to integrate it only in this range. Okay. Without limit, I have just given you the curve and I told you integrate it. For example, this is the curve value, and I said just integrate it. Okay. So in this case, you have to put a constant. Understood the thing? For example, this. Right now we are doing differentiation without limit. Okay.
Okay, sir.
When we do differentiation without limit, that is called as indefinite integration. When we do it with the limit, that is called
So
as definite integration. Yeah, what happened?
we are supposed to add the constant.
Yeah, we are supposed to add a constant in case of indefinite integration.
So what's the answer, sir? Now for this
This
one,
thing, x cube plus 3, this is the answer. Okay.
x cube plus c.
Yeah, see. Okay, now how
Okay,
these
sir.
things are helpful you. Assume I said that, um, okay, what I'm saying, Bhavna, let's say another question. I'm saying this dy is given as how much? Okay, let's say the dy by dx is given as Bhavna 3 value. Okay, 3 is given to you. I am saying y of 1 is given as 2. Calculate y is equals to 5. How you can do this part? Okay, no, this value you have to calculate. How you can do the Bhavna? You know this equation, right? If you take this, you can write this as this. If you integrate it, integration of dy mean to say you are going to take all the values of y. We already know how to integrate this part. Bhavna, do you know how to integrate this thing? This is nothing but 1 here, and here this is 3. Bhavna, this, you know what is the integration of 1?
So integration of 1.
Yeah, what is the integration of 1? That is the value itself, right? That is the
Yes,
what.
sir.
So here I am doing it with respect to y. So here I will be getting y plus c. Look, now here I can have one constant from here, one constant from here. So I will be writing it as c1. Okay. This side I already have 3. I will take it outside. From here I will be getting x plus c2. So what I am going to get is y is equals to 3x plus c. What is the c? C is nothing but c2 minus c1. Basically the final constant of the whole equation. Is that clear, Bhavna? Now if you see, I have got the equation of y. What was my question? It says when you put y is equals to x, basically this y, x is a function of, like y is a function of x. When I put the x is equals to 1, I am going to get the y is equals to 2. So if you put the y is equals to, like, x is equals to 1, what you are going to get the y as 2. So from here you are getting c is equals to how much? Minus 1. So what is the final equation we have got now? That is 3y is equals to this minus 1. Understood how this is beneficial?
Okay, sir.
Make sense? Now you can see, now if the
Yes, sir.
question asks you, give me the value of y is equals to 2. If the question now asks me, what is the value of y is equals to 5? I can simply get, right? I will put the y 3 into 5 minus 1, 14. Question says, give me the y is 10. 3 into 10 minus 1, 29. Clear?
Okay, sir.
This is how it is useful for us. Okay, it means, just remember some integration formula, that integration of x dx, integration of dy. When I say dy dx, only thing it means, if nothing is there, you can see it is a multiplication thing, so you can assume 1 is there. Okay, or in another way, Bhavna, just look at this. Integration is nothing but adding up, right?
Yes, sir.
It means I am going to add a small portion of xx. How I am going to get x? X is dx is basically, I must had some bigger picture of x, right? And from there I have taken this smaller x's. So when I took add, this is x, this x, this x. When I add all these x's, am I getting? Am I going to get the x value itself?
Yes, sir.
Okay, it's basically the integration, just like we used to do. So if you get integration of dy, z, any different value, like if you are given du integration, u only, dv, whatever you have given, you can simply put v. Understood my point?
Okay, sir.
Because the question says, it is very simple thing, like I give you 5 value, 5 meter, and if I make a small portion like 1 meter, 1 meter, 1 meter, if I say, okay, do integration of this 1 meter 5 times, 0 to 5 times, what does this mean? You are going to integrate 1 plus 1 plus, at the end
It
of the day.
comes out as 5.
Yeah, so the same is here also. Okay, so Bhavana, I won't go much more deep into this. I'll write 2 or 3 more formula, okay? And then you can just try some formula,
Okay,
like
sir.
problems based on this.
So you'll be giving them as homework?
Yeah, I'm writing formula. Just 3 to 4 formula, okay? Not much depth problem. So yeah, this
Okay,
is
sir.
dx. I have already done. And this is ax dx. So you know what is this? Very simple. Although I don't have to write this. Take it outside. Integration of x dx plus c. Never forget putting a c. No, not this. Fx. When I write this, it means function of x, function of x. Okay? The whole thing is with this single integration can be written as, so Bhavna, this is all about the three formulas I am giving, not much more than this. Okay. We'll discuss the much many formula in after the class. Okay, in the next class. Understood?
Okay.
Wait a second. If I have some problem, I can give it to you. Okay, you can write one more formula, that is integration of sin x dx. It will be nothing but minus cos x plus c. Integration of cos x is nothing but d. So that is the another formula. So you can just try out some questions. Questions I am giving you: x square plus sin x
So
plus
I'll be
3.
doing it as homework.
Yeah, if you want, you can do. If you like, you can do it as homework. Okay.
Like give few of the sums, sir. I'll be doing it and I'll be sending to Manisha ma'am.
Okay, no problem. You can 3x square dx. And these are more than enough, I think. Like, we have not discussed much properties here. One more thing here, the chain rule doesn't work like that. Okay, so if you can't
Okay,
do
sir.
like, you can't do simply like this what we used to do in case of what was that, differentiation, right, where we do not
Differentiation.
two outside then this and this. Here you can't do this. Okay, here we have a proper different method
Okay,
to
sir.
solve this. We will discuss that also. Just do
Okay,
these
sir.
two problem. Okay, all I think. Okay, don't share it to me, you can just try it. Okay, if you are able to do it, that's fine. Okay.
Okay, sir.
Yeah, so that's all for the today's class. I will share this PPT.
Okay, sir.
Yeah, goodbye, Pama. I'm ending the session. Bye.
Okay, sir. Okay, sir.